A few final considerations here. So indicators. So we have a lot of different indicators. Some indicators can indicate over the entirety of the full pH scale. Other indicators, most other indicators, indicate in a very narrow range, usually plus or minus 1 pH unit of what is called the pKa. So if I look at this indicator here, I have a pink color, then an orange, and then yellow. So this indicator goes pink to yellow. Okay, so as it's going from pink to yellow, I end up with a mixture of some pink molecules and some yellow molecules. It doesn't just all happen at once. So if I mix pink and yellow together, what color do I get? I get this mid color, this orange here. So that's that halfway point between transitioning them. Okay, this one is going from yellow to blue. That middle one there, it's kind of this like grayish color. It's supposed to be green because if I mix yellow and blue together, it's just the way these mix is so faint, and so you end up getting this kind of like grayish greenish color in the middle there. My last one is phenolphthalein. It goes from that colorless to pink, and so right as you get to an endpoint of a titration with phenolphthalein, you get this super, super faint pink color. And so we get color changes at various different pHs. Okay? There's a ton of different indicators. A lot of labs will have a chart of indicators and it'll show the colors and the range it goes across. And so when you're doing a particular reaction or titration, you can ballpark where your ending pH is going to be if you know something about the species that you're working with. And so from there, you can make an informed choice. So if you know that your end point is going to be in something that's slightly acidic, maybe you use this methyl red. If you know it's slightly basic, maybe use phenolphthalein. If you know it's a little bit more basic, maybe you pick a different indicator. If it's something that's more acidic, maybe you pick a different indicator. And so you can use an appropriate indicator for each reaction. One other thing that we have to worry about is if our rain is acidified. So here's a statue that started off like the picture on the left, and over time it ended up like the picture on the right. Because what happens is things erode. And how does this erode? Well, marble is calcium carbonate. Okay. If I put water on marble, it's not going to do anything. But if I put acid on marble, it will. If I have an H plus ion, like I would have if I had acidic rain, okay, what ends up happening is I get some calcium ion, I get some water, and I get some carbon dioxide gas. Because this H plus ion, and I actually will need two of them, I have an H plus ion. If I have a proton and I have carbonate, what I get is this carbonic acid. Carbonic acid is unstable, and as soon as it forms, we get water and carbon dioxide gas. And so if I form water and it's raining, that's going to wash away. If I form carbon dioxide, it's going to bubble away. And so my acid rain will react with marble, and eventually it will erode away the marble. Another thing to consider is cars. So you got your body panel, and then there's a substrate primer that goes on there, and then you get the base coat, which is the color of your car, and then you get the clear coat over it. The clear coat protects all of that, but lots of things can damage your clear coat. You can scratch it, it can get oxidized, you can get acid rain that etches it away. And so if you etch away your clear coat, then you're getting to the base coat. That usually you can damage that, and then eventually you can get down to the body panel. And if you get down to the body panel, then you can start rusting away the metal. So if you've ever had your car repainted, they will actually give you a little notice that says don't park under a tree. They don't want you to park under a tree because the likelihood of bird droppings getting on your car is much higher if you're parked under a tree than if you're not. Bird droppings are very acidic, and it will eat away at the clear coat. And the clear coat is still curing when you get your car back from being repainted. Somebody hit me one time, and I ended up having to have the whole car repainted so that it would match if it faded. And I was leaving on a trip, and I was living with my parents at the time, and my dad is a car guy, my brother's a car guy. I told them, hey, don't forget, don't park my car under a tree while I'm gone. I did not park it under a tree. I came home and they had moved my car under a tree, and there were 2 spots where bird droppings had got on it. I washed them off, and forever I had 2 discolored spots on my car from where those bird droppings hit it because they had eaten away at so much of the clear coat that it left part of the base coat open to air, which reacted differently. And so I had 2 discolored spots on my car for the rest of the time I owned that car because the acidic stuff had eaten away at the clear coat. So if you live in an area where you get acid rain, you end up with your clear coat getting etched away at. So we have to be careful about acids in our environment.